Дорогие участники международной конференции Skolkovo Robotics, приветствую вас в старой народной космической станции. Предсказания писателей фантастов свершились. Сегодня роботы точно вошли в нашу повседневную жизнь и стали неотъемлемой ее частью. Научный технический прогресс не стоит на месте, поэтому даже сложно предугадать, на какой уровень выйдет взаимодействие человека и робота в 21 веке. Но ясно одно, оно должно быть направлено на увеличение эффективности труда жителей нашей планеты. Роботы не только помогут человеку на Земле, но и в космосе. В 2011 году на Международную космическую станцию был доставлен космический робот по имени Робонавт-2. С тех пор он является полноценным членом всех экипажей станции. Желаем вам успешного проведения конференции по робототехнике. Искренне верим, что с помощью технологического конкурса, который Сколково планирует объявить по итогам конференции, будут созданы прорывные технологии, способные изменить жизнь людей на Земле к лучшему. Мы уверены, что в недалеком будущем человекоподобные роботы станут неотъемлемой частью пилотируемых космических миссий и будут крутиться с нами бок о бок, помогать развивать космос и раскрывать тайны Вселенной. С космическим приветом 34-я экспедиция на Международную космическую станцию Олег Новицкий, Евгений Тарелкин и Роман Романенко.
Как вы понимаете, один из них робот, о котором была речь, но в конце мы скажем, кто из них робот.
Floor, what angle the floor is, and where boxes are. So that's one of the techs we developed. The other tech, going on to the next slide, let's hope that. So calibration, extremely important in robotics. If you can't, you got a camera, if you can't coordinate that where the hand is, it's not going to do you any good. You won't be able to manipulate things. You can't coordinate the camera precisely with where the robot is, you know, the robot's going to go off a cliff. So we've gotten quite good at this, and here, this is tool measurement. That's a welding tip right here. And all that's being done is in a simple web camera. There's a diffusion screen. We've just calibrated this camera, and we're just watching this. And what it's doing is forming a 3D model of where this is. I don't know if you can see, but I have a little software, I wrote this, that's finding the tips and ends of this. And it's just recording the movements over time until we get it. And so you see this is offset from this giant arm. It's offset, but it's able to spin it on a pin just by waving it around. Well, anytime a robot uses tools, the tools get bent, and you better be able to calibrate it. So this is one of the core techs that we're building on. Moving on. 3D models, done. We've gotten extremely good at this. So, final tech, I think, is in object recognition. Not only knowing, you know, what the object is, but where it is. This is a real-time training of it. This is the models that you just saw captured. So, in general, what we do is we capture a 3D model. The robot trains itself using the 3D model and then uses it to recognize. So it's hard to see here. See that clamp when he grabbed it? There's no thumb there. That's because we're overlaying the model, showing that we know precisely where this thing is. This video is not sped up. We do this in real time. So we know what object it is and the pose. And this is like our foundational tech. We're very good at 3D object recognition. Right now, rigid objects, but there's plenty of rigid objects in the world. We can wait on the general case and where it is. And where we've applied that is, come on, one more technique. Because the cameras aren't good enough yet, this might stop running, but you see this is from a Kinect camera. It has a lot of noise. The noise is approximate of the level of the seam between boxes. And so what we do is we integrate, using the motion of the robot, we integrate onto the surface and get a nice clean view where we can go. So here's some of the things that we're doing with it, which is truck unloading. See, it's a boring job, unloading trucks. Well, count the number of trucks on the road and you'll see this is a big area. Probably it's at least 50% of the economy. Just moving objects around. this item, I got it in my hand. How did it get there? I don't know. It probably was made in Japan, China, got transported somewhere, got to here, got to to a distribution center here, got to a store. Someone brought it. Well, it had to get to my hand. Everything you're holding, everything you're sitting on had to get to you. And it's getting there primarily this way. And so, what we have is this well, here we're doing loading. This is driving back into a truck and is going to find these boxes and start loading them. This is a view from the robot arm of grabbing the boxes and unloading them, so it'll grab that box, move around, put it on the conveyor belt. This is unloading tires. So the basic stock of the economy is being done here. And soon, these lights are just for film. It has its own light. But so it drives way to the end of a truck, creates a 3D model of what it's looking for, and then uses that to plan and unload. So our job here, boxes might be an easy item, you think, easy thing to do, they're boring, but we have to do these fast, and it can't fail. Right, so if we have one error in 1,000, 99.99%, it's not really good enough because the box, we'll need too much human intervention. It won't be profitable. So the numbers we have to hit, we're not there, but we're on the road, is we have to reliably unload trucks at 1,000 boxes an hour. That's box every 3.5 seconds. If you think about this is fast. and so we're creating designs that will achieve this spec. If we achieve that